In this section, we are just getting information from the graph of a function. So if you're given the graph, you should be able to read it. Function value of f, that's f of a, is the height of the graph above the x-axis at x equals a. So if you want to see from the graph, f of 3 is the height of the graph at x equals 3. So how high is that? That's 4. And f of 1, the height at 1 is 1. And so the net change is from 1 to 4. So f of 3 minus f of 1 is 4 minus 1 equals 3. Now, if f is decreasing on an interval, then the values of the points on the graph are getting smaller as the x values increase. They're getting smaller. And so f is decreasing on intervals on the x-axis. We have to look for the x values. So let's clean some of this off here. There we go. Okay. Decreasing, the function is decreasing as the function value is a peak here and it's a valley there. So it's decreasing in this part. The x values are, the x value here is 2 and the x value here is 4. So on the intervals from 2 to 4. And on the second interval, we have another peak, and it's going to decrease forever. The x value here is 5. So 5 to infinity. So I'll let you do the maximum and minimum things here. Next slide, we looked at some more function values from a graph. So h of -2 means locate -2 and read the function value. The function value is 1. H of -2 is 1. H of 0 is -1. H of 2 is 3, and h of 3 is 4. The domain is the set of x values that have y values. So if we start at x equals -3, we'll find points on the graph until we get out to x equals 4. So the domain is -3 to 4. The range is on the y-axis, and the first point that we have a y value is -1. And we'll see points in the graph as you go up the y-axis all the way up to y equals 4. So -1 to 4 is the range. The values of x for which h equals 3, well, let's erase some of this off again here. So h equals 3 is a horizontal line, at the height of 3, right there. It's your horizontal line, h equals 3. That crosses our graph, or is equal to h of x exactly 3 times. Right there. So, so we see that we have 3 x values, and those x values are -3, +2, and +4. So 3 x values for which h of x equals 3. X values for which h of x is less than or equal to 3 are going to be all the x values, let's see, from -3 to +2. Because for these x values, the graph is actually above y equals 3, right? Above 3. So we only want the x values between -3 and +2. So -3 to +2. So I'll let you do the net change. Remember, it's going to be h of 3 minus h of -3. Practice reading points and things on graphs by looking at this one on your own. And so we did the domain and range. We actually drew a graph of the square root of 16 minus x squared. We found that that's actually a half of a circle. It's the circle of radius 4 centered at the origin. So these 3 points are 4, and we draw this half circle. So that's 4, that's -4, and that's 4 on the y-axis. So the domain is the x values. The x values go from -4 to 4. The range is the y values, and the y values go from 0 to 4. So there's your domain and range. And just more on where functions are increasing or decreasing. And to find the domain and range of this function, we graphed it, and I think the graph looked like this. Came to a little point there, and then it was symmetric. So the domain, these can extend forever. The domain is all real numbers. The domain is minus infinity to infinity. And the range is, well, the first value we see on the y-axis is 0. The range creeps up the y-axis. So the range is, I'm sorry, that should be a bracket, 0 to infinity on the y-axis. Again, you can practice reading a graph by doing this weight function problem on your own. And we did local maxima and minima from the graph by using a function on the calculator. The second function of the trace button is calc. That's the second function of the trace button. It's calc. And two options are min and max. Maybe it's minimum and maximum. And that's where you do a left bound, right bound guess type of thing. So we practiced a little bit of that in class, so make sure you can do that to find local max and min graph. We worked on this problem. If you read this problem, you find out that basically what you want to do is maximize this function right here. And so it's a matter of entering it correctly into the calculator. You'll need 88s, and let's put parentheses around that. And then parentheses for the denominator, 17 plus 17 times s divided by 20. You need parentheses around that, and then squared like that. And that should give you the correct function, and then you want to do max of that function. So use your calculator to do that problem.